Good morning students. Thank you very much students for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section I'm going to discuss about the oxidation and reduction potentials of hydrogen electrodes. How to find easily oxidation and reduction potentials of hydrogen electrodes students. This topic is from electrochemistry. Okay, now from second PUC. Here I'm taking the Daniel cell students. Here this is the salt bridge and these two are the electrode students. Okay, one is zinc electrode, another one is copper electrode, one is acting as anode, another one is acting as cathode, correct? So this is anode, this is cathode. Here this is the solution, 1 molar zinc sulfate, 1 molar copper sulfate students. Understanding, amma? So suppose here this voltmeter is giving the potential difference, it is giving, okay, na potential difference giving. Suppose I want to find the zinc electrode potential, individual electrode potentials, we can find. Here we cannot find because the voltmeter is giving the only electrode potentials difference. I want to find individual electrode potentials, it is highly difficult to find that one. So that's a one standard electrode potential, standard electrode, electrode should be there. Then by using that we can find the unknown electrode potential students. Are you following? So that's a one reference electrode we are taking, that is a standard hydrogen electrode, that is Shenan. Its electrode potential how much students? Standard EMF of the cell, what is the standard electrode potential students? She 0. Are you clear this one? So standard electrode potential of She is equal to 0. So now I am going to calculate the She reduction potential and oxidation potential students. Before that, She, why we are using students, it is this potential, we know that this potential how much students? 0. That's why we are calling as standard. Are you following? Clear this one. So which electrode potential, we know that potential will call it as standard electrode potential. Understanding students? So that's a word, the standard is used, that means the known potential. And next thing, here I want to find the only zinc electrode potential. How to find it? Students? So that's why here, if suppose zinc electrode is acting as anode, then She, if you take the reference electrode here, because we know that potential is 0, then voltmeter is showing the a potential difference. That value, what it is showing, that value is equal to the zinc electrode potential, correct or not? So that's why here we are taking one reference electrode we are taking students, that is the standard hydrogen electrode. For example students, in kirana shop, suppose we ask 1 kg sugar, how he will measure shop boy? By using 1 kg stone, correct? By using one reference stone, one standard stone, that is 1 kg stone. By using that, he will measure 1 kg sugar. Yes or not? Like that only here also, to measure the unknown electrode potential students, we have to use one standard electrode potential. Are you clear? One standard hydrogen electrode you are taking, that is acting as a reference electrode, because we know that electrode potential 0. Are you clear this one? Okay, now suppose I want to calculate, suppose now I'm going to calculate students oxidation potential. That means what students? Because we know that at anode which reaction is taking place? At anode, oxidation reaction taking place always. Okay, now at cathode which reaction taking place? Reduction reaction taking place, correct? This is reduction reaction taking place. Understanding, Nana? At anode oxidation, at cathode reduction. If suppose I want to find, suppose here I am taking the copper electrode as a cathode. To find this electrode potential, She is acting as a it is acting as a anode hydrogen electrode. Are you clear this one? It is acting as a anode students. Clear, amma? It is acting as anode. So first anode, at anode which reaction is taking place? Oxidation reaction is taking place. Now She is, how She is acting? It is acting as a anode, and it is understanding here. I'm not taking the zinc electrode students. I'm not taking the zinc electrode. What I am taking? Hydrogen electrode I am taking. Okay, now here copper electrode, this is the hydrogen electrode. Now it is acting as a anode. At anode which reaction is taking place students? Oxidation reaction taking place, correct? What is the oxidation reaction of She? What is the oxidation reaction? Loss of electrons, correct or not? Loss of electrons. And what is the reaction is taking place here at anode? Oxidation reaction. Half mole of H2 gives rise to H plus electron, correct, amma? So here to one hydrogen atom, here also one hydrogen atom, by loss of electron. This is the oxidation reaction at anode, this reaction taking place. Okay, and oxidation is nothing but what students? Loss of electrons, loss of electrons. Understanding? So loss of electrons. So this reaction is taking place at anode. Now I want to calculate the oxidation potential. Okay, now this is the oxidation reaction. So that's the oxidation potential we can calculate for She. Okay, now hydrogen electrode, standard hydrogen electrode. So how to find it? See students, I am taking here one formula. E cell is equal to what we can write? E naught cell minus 0.0591 by n into logarithm of q base 10. This formula I am taking. Here q is nothing but reaction quotient, students. That is, it is simply it is equal to the equilibrium constant also. This is a reaction quotient. Now see students, here q is nothing but here product of the that is concentrations of the products by concentration of the reactants. What is the equilibrium constant formula? Equilibrium constant is nothing but products concentration by reactants concentration. So like that you have to take. Okay, now from this here oxidation reaction I am going to calculate the q value here. So what is the q? What we can write, students? Product of the concentration of the products by product of the concentrations of the reactants. Now here what is the reactant? What is the product, students? H plus ion. So H plus ion concentration by here what is the reactant, students? H2. Okay now. So H2 is a gas, correct? H2 is a gas now. So that's why we cannot this one we have to take partial pressures. In terms of partial pressures we have to take. Okay now, because it is in the aqueous state, so that's why H plus ion we are taking the concentration, but here H2 is in the gaseous state. Okay, so that's why we are taking the partial pressure. So partial pressure of H2, and how many moles are there? 1 by 2 moles are there. Are you clear, students? Partial pressure of hydrogen and 1 by 2. This is Q value. Okay now this value here I am going to substitute. And what is E naught cell value, students, for She? Okay now E naught cell is equal to how much for She? 0 minus 0.0591 by n. N means how many electrons transferred. Here this is hydrogen electrode, this is the copper electrode. How many electrons lost? This one electron is lost. So that's why here 1 electron only transferred from She to cathode. Are you clear? So 1 electron is transferred. So that's why n is equal to 1 into logarithm of what is Q value? H plus ion concentration by partial pressure of hydrogen. Here how many moles? 1 by 2 you have to take in the powers. Clear this one? So this value you have to take now. Understanding? Now see students, here E cell is equal to what we can write? Minus 0.0591 by 1 into logarithm of this one partial pressure of hydrogen. If suppose partial pressure of hydrogen, how much, students? It is equal to 1 bar. So partial pressure of hydrogen is equal to how much, Nana? It is equal to 1 bar, students. Clear? It is equal to 1 bar. Now here substitute partial pressure of hydrogen is equal to 1 bar. Then here what you will get, students? Logarithm of H plus ion concentration by 1. This value is equal to 1. Partial pressure of hydrogen 1 bar. 1 to the power of 1 by 2 is nothing but 1 only. So E cell is equal to what we can write? Minus 0.0591 by 1 into logarithm of H plus ion concentration. Correct? So minus this one. Now from this equation what we can write? 0.0591 by 591 into minus logarithm of H plus I am taking here. Minus I am taking here, Nana. So minus into logarithm of this minus this log H plus I am taking. From this one what we can write? We know that minus logarithm of H plus is nothing but pH. Correct? This is which potential, students? This is the this is oxidation potential kada. This is oxidation reaction is taking place because here She is acting as a anode. Which is acting here? She is acting as a anode. Okay, now that's why anode oxidation reaction taking place. That's why we calculated oxidation potential. So this is the oxidation potential, students. Here are you clear? This one, this is the oxidation potential. Suppose I want to find the reduction potential, students, then what you have to do here, just you have to take the minus sign. Are you clear this one? How to find it, reduction potential? Just you have to change the sign, that much only, that's it. Okay, see here, E cell is equal to minus 0.0591 into pH, minus 0.0591 into pH. This is which potential? Reduction potential. Are you clear? Reduction potential. Understood, Amma? This is reduction potential. So what is the reduction reaction here? At hydrogen, reduction reaction means, if suppose hydrogen, she is acting as a, now she is acting as which one, students? It is acting as a cathode. Okay, not copper. Now it is acting as a cathode. Now zinc is acting as which one, students? Anode. Okay, now it is acting as anode, she is acting as a cathode. Now at cathode, which reaction is taking place? Reduction kada. At cathode, reduction reaction is taking place. What is reduction reaction? Just you take, reverse this reaction, that is a reduction reaction. That means H plus by gain of one electron, it becomes half H2. Are you clear? So from this equation here, what we will get, Q value. So Q value is equal to what we will get, partial pressure of hydrogen to the power of 1 by 2 by H plus ion concentration. This value 1. Then Q value, how much? 1 by H plus you will get. Are you clear this one? 1 by H plus. So here if you substitute 1 by H plus, in the case of logarithm, here 1 by H plus, okay, now you will get the negative value, students. Understanding? See here, suppose this is substitute nana here. This is which potential we are calculating? Reduction potential kada. Now see nana. See here, I am going to calculate, this is the Q value. Now here substitute in this formula Q value. Then what you will get, nana? E cell is equal to what you will get? E cell is equal to E naught. Okay, E naught cell value how much? 0 minus 0.0591 by N into logarithm of partial pressure of hydrogen value 1 by H plus ion concentration. Correct? So 1 by H plus ion concentration. So we know that pH is equal to, what is the formula? pH is equal to minus logarithm of H plus ion concentration. Correct? So that means 1 by logarithm of 1 by H plus is nothing but what we can write, this one, logarithm of 1 by H plus is equal to pH. So that means this value, N value 1, then how much you will get? Minus 0.0591 into pH you will get. Understanding, students? This H plus ion concentration, what we can write? If it is go to numerator, H plus concentration whole to the power of minus 1 into log H plus is nothing but pH. Are you clear? So this is the negative value you will get. Okay, now this is which potential? Reduction potential. Are you clear? So this is the reduction potential. So just you remember these two formulas, students, then you can find the oxidation potential of hydrogen and reduction potential of hydrogen. See this problem, students, here. Okay, just you write two formulas here, then you can find it. So what is the oxidation potential of hydrogen, students? What is the oxidation potential of hydrogen? Solution. What is the formula, students? E cell is equal to oxidation potential, we have to find it. So oxidation potential formula what? 0.0591 into pH. That is the oxidation potential. Okay, Rama, just here we calculated oxidation potential. La. Just you change the sign. This is positive, this is negative. Negative is reduction potential. That much only. Okay, na? So here how it came? Here I discussed, students. Clear? Okay, now see, Nana, here. Oxidation potential. What is oxidation potential? 0.0591 into pH. Clear this one? So here how much given, students? pH value 10 value given. Okay, now pH is equal to 10 given. Just you can multiply. Then E cell is equal to what we can write? 0.0591 into pH value how much given? 10 given. So into 10. So how much you will get, students? This answer? 0.591 you will get. Correct? So 0.0591 into 10. How much, students? 0.591. Correct. 0.591 volts you will get. Understanding? So this is which one, students? This is the oxidation potential of hydrogen. Okay, now so just you remember this formula, students. ESL is equal to, this is the which potential? Oxidation potential. Clear? It is the oxidation potential formula, students. Okay, nama oxidation potential formula. Okay, now see next, what is the answer? 0. Plus 0.591. Okay, now what is the correct option? This is the correct option. It is nearer to this one. So option C is the correct one. Now what is the reduction potential, students? Second question, see here what asked. The reduction potential of hydrogen electrode at pH is equal to 10 is asking reduction potential. What is the formula, students? Reduction potential, just you have to change the sign, here positive, here negative, that much only. E cell is equal to minus 0.0591 into pH. So then minus 0.0591 into pH value how much? 10. You will get minus 0.591 volts. Clear this one? So this is the reduction potential. So this is the formula of reduction potential. This is oxidation potential. This is the reduction potential, students. Clear this one? So just you remember these two formulas, students. You can easily answer this type of questions. Understanding? These are the previous year's questions, students. Okay, Namma. Understood, students, how to find it? Okay, now how these formulas came, here I discussed you. Okay, here I discussed you, students. Okay, I hope you like this video, students. Thank you very much, students. If you like this video, please like, share, comment and subscribe my channel, Nanna.